Okay, so this is technically the first day of the new lesson for chemical reactions. The first thing that you need to do is make sure that you understand all of the notes on this page from the very beginning. This is a very important page of information. A lot of this information will be seen on the test. We will start from the beginning. It gives you a reaction. Then there's the yield sign, yield as in Y-I-E-L-D, and then the products, meaning that you will have two things. I'm calling them things at this point because they could be compounds or they could be elements. Just depends on what type of reaction we have. But you would add the two reactants on one side and they will bond together on the side of the product. So the reactants will produce the products. It's very important that you understand the difference between a coefficient and a subscript. The coefficients are the numbers in front of these compounds, and the subscripts are the little numbers in between. Little numbers, notice how they go down further, just like a submarine, and so that's where the prefix sub comes from. It means under. Okay, so it is important for you to realize the definition of a chemical reaction, where bonds are broken on the reactant side and they are formed on the product side. That's a very important detail for this chapter. It would be a good idea to take the time to remember what indications of a chemical reactions are. We've actually already done this lab, so you might remember that anytime there's a change of odor, color, gas bubbles, light, heat, or if there's a precipitate, that means that a reaction has formed. Now don't forget that a precipitate is simply just a solid. If a solid is formed, that means that a reaction has occurred. Activation energy, just another term you're just going to need to know, maybe do a little Quizlet, but it's the energy required for a chemical reaction to occur. You need to know the term catalyst, which is something we have talked about before, something that quickens the pace of the reaction, but it does not affect the reactants that are within this equation. Then you should know that if we have a solid in a chemical reaction, then it's shown as a little S with parentheses. So when you look back up here, we have an example of your typical chemical reaction, and it shows you the little AQ or L or AQ here. These just represent what state of matter they are, if it's a solid, liquid, or gas. So the hydrogen phosphate would be an aqueous. Potassium hydroxide is aqueous. And don't forget that aqueous just means it's a solution that's dissolved in water. If it says L, it's a liquid, and if it says S, it's a solid. And of course, a G represents gas. Okay, you need to know the difference between an exothermic and endothermic reaction. We have talked about how exothermic reactions release energy and how endothermic reactions absorb energy. One way of seeing this in a chemical reaction is to look to see where the energy is shown in the formula. So on top here for exothermic, as you can see, the energy is written on the right side of the equation where the products are. If you see it on the right side, it's automatically an exothermic reaction where the energy has been released. If it's on the reactant side, on the left side, then that means that it's endothermic and this energy has been absorbed. It is very important to make sure you know the different types of reactions. Take the time to make note cards and study these. You will have a quiz on these, and the quiz does not give you any matching choices. You have to remember these terms. We have synthesis, which is used anytime you have two different elements and they form to make one big compound. And then they give you an example here. Decomposition, if you have one big compound and it's broken down into two smaller parts. And then they give you an example over here. Combustion can be one of two forms. There's either the hydrocarbon with oxygen, and it always produces carbon dioxide and water. But also, do you see this little triangle? You need to know that that means that heat has been added to this reaction. Combustion is usually whenever we have fire or heat added to the reaction. This gives you an example of a hydrocarbon. Notice how it's made up of a hydrogen and a carbon with oxygen, and again, it always forms carbon dioxide and water. This is a good one to memorize because you will see it time and time again. Then the other type of combustion reaction is when you have a metal and an oxygen to form a metal oxide. We have an example here. The next example is where we have a single replacement, where you have a single element and a compound and they switch only one single replacement and then double replacement here. So let's practice.